Hello students, today we are going to discuss entropy statement of second law of thermodynamics. The statement is the total entropy of the system and surrounding increases in a spontaneous process. A spontaneous process means a process that occurs by itself, and it is a spontaneous process because it does not need any external agency. For example, water falling from a height, melting of ice, ball rolling down a slope. These all are spontaneous processes, and according to second law of thermodynamics, entropy means molecular disorder always increases of the system and surrounding in a spontaneous process. Let's understand this statement with an example. You know that melting of ice is an spontaneous process. Then consider the molecules of ice are arranged in a definite order. Since the ice not melted yet, so the ice molecules are in an ordered state. When ice melts, this highly ordered crystalline arrangement of water molecules collapses and molecules become free to move in a liquid. A sort of ordered state becomes a disordered state as shown in figure. When liquid water vaporizes, the gaseous water molecules move freely and randomly in entire available space. A less disordered state becomes highly disordered state as shown in figure. Thus, in the melting of ice and vaporization of liquid water, disorder or randomness of molecules increases. Such a molecular disorder or randomness is measured by thermodynamic property called entropy. For a given substance, the crystalline solid state is the state of lowest disorder and lowest entropy, and the gaseous state is the state of highest disorder and highest entropy. Thus, entropy of a substance increases as it passes from solid to liquid to gas. It follows then that in melting of solid and vaporization of liquid, entropy changes. Delta S of the system is positive. The entropy change of a system in a process is equal to the amount of heat transferred to it in a reversible manner, divided by the temperature at which the transfer takes place. Thus, delta S equal to Q reversible divided by T, where Q reversible is the heat transferred to the system, T is the temperature of the system. The amount of heat Q is expressed in joules and T in Kelvin. The units of delta S will then be joule per Kelvin. The total entropy of the system and surrounding increases in a spontaneous process. Then second law of thermodynamic equation can be stated as below. Delta S universe equal to delta S total equal to delta S system plus delta S surrounding. Thus, if delta S universe greater than 0, the process is spontaneous, means delta S here is positive. Second, delta S universe less than 0, the process is non-spontaneous. Here means delta S is negative. Third, delta S universe equal to 0, the process is at equilibrium, means delta S is 0. Let's take the example of our day-to-day life. When we keep the cup of hot coffee on a table, what's happened? The hot coffee will become cold after some time. In thermodynamics terms, we can say that hot coffee loses heat to the surrounding. Well, in this cooling of coffee, the entropy plays a very important role. Let me show you this with a mathematical proof. Assume that the temperature of coffee is 50 degrees Celsius. The temperature of surrounding is 20 degrees Celsius. Now, there are two possible cases. The coffee may absorb heat from the surrounding or the coffee may release heat to the surrounding. But what will happen from these two cases? Let's find it out through some calculations. Case first, coffee is absorbing heat from the surrounding. Let's say coffee absorb 10 joules of heat from the surrounding. That means the surrounding will lose 10 joules of heat. So we can write Q system equal to plus 10 joule, Q surrounding equal to minus 10 joule. Now change in entropy of universe is given by equation. Case first is coffee is absorbing heat from the surrounding. Formula is delta S total equal to delta S system plus delta S surrounding. Again we put the value of delta S delta Q system divided by T system plus delta Q surrounding divided by T surrounding. Let's put the values of Q and T. Here delta Q system's value is plus 10, T system is 302.3 plus delta Q surroundings value is minus 10, T surroundings value is 209.3. We have delta S total equal to minus 0.0316 joule per Kelvin. This is a negative value. The entropy of the universe is decreasing here. Thus, it violates the second law of thermodynamics. So, we can say that this thermodynamic process is non-spontaneous. This process of absorbing heat from the surrounding will not occur on its own. Case second is coffee is releasing heat to the surrounding. Let's say coffee releases 10 joules of heat to the surrounding. That means the surrounding will absorb 10 joules of heat. So we can write Q system equal to minus 10 joule, Q surrounding equal to plus 10 joule. Now change in entropy of universe is given by equation delta S universe equal to delta S total equal to delta S system plus delta S surrounding. Let's put the value of delta S. Delta Q system divided by T system plus delta Q surrounding divided by T surrounding. Now let's put the values. Delta Q system's value is minus 10, T system's value is 302.3 plus delta Q surroundings value is plus 10, T surroundings value is 209.3. We have delta S total equal to plus 0.00316 joule per Kelvin. This is a positive value. The entropy of the universe is increasing here. Thus, it satisfying the second law of thermodynamics. So, we can say that this thermodynamic process is spontaneous. This process of releasing heat to the surrounding will occur on its own. वीडियो अगर अच्छी लगी तो लाइक करें, चैनल को सब्सक्राइब करें. Thanks for watching.